Welcome to our newest conversation of Let's Talk About Hanford. Tonight's topic is the Hanford Site's Waste Treatment Plant. To cover this, we have invited Suzanne Dahl, our tank waste treatment section manager. My name is Ana Alvarez, and I am in the communication section at the Nuclear Waste Program. Just a reminder for everybody seeing us, we're having issues getting to the Facebook version of this stream running, but we are sharing the Zoom link on Facebook while we try to get the Facebook streaming going on, hopefully. A little bit of intro on the series. We started the Let's Talk About Hanford series back in 2020 to cover Hanford-related topics at a high level. We will continue doing so for as long as the interest and participation from the public continues. And on that note, we wanted to thank you, all of you, for being here tonight with us. And I think now I am going to introduce you to one of our newest members of the communications team, Sarah Williams, who is going to be my co-host tonight. Welcome, Sarah.
Thank you. As Ana Grisel mentioned, I'm Sarah Williams. I am one of two community outreach specialists for Ecology's nuclear waste program. My position focuses on environmental justice related to the Hanford cleanup. Regarding tonight's presentation, we ask you to please put your questions or any comments you might have into the Zoom or Facebook Live if we get that going at any time. After the feature presentation, we will have a live question and answer session with all of you. So you can ask your questions through the chat, which will be read by one of us. Or if you're not shy, you can ask your question out loud by putting your name in the chat box or raising your hand, and one of us will call on you. So we encourage questions and comments geared to tonight's topic, which is the waste treatment plant at Hanford. But if you have any other questions or comments about Hanford, nuclear waste, or Washington ecology, please email us at hanford@ecology.wa.gov. Back to you, Ana Grisel.
Thank you so much, Sarah. So as I mentioned, we are going to talk with Suzanne Dahl. She is our tank waste treatment section manager, and she has been tackling tank waste with our nuclear waste program for 30 years. So without further ado, just let me welcome Suzanne for tonight's event and thank her for being here with us tonight. Suzanne.
All right. Thank you very much. I'm glad that everybody's joining us, and thank you for the introduction. And I guess I'll wait until we get some slides up and then I'll start going. But it's really exciting to have people here and to be able to talk about this really exciting piece of work. And we're at a very exciting time for it too. So we're going to talk about the waste treatment plant. And now there's other things going on tank waste treatment that are exciting, that have come out of a thing called holistic negotiations, and we'll perhaps talk about those in a different venue at a different time. But today we're going to talk about waste treatment plant, and I'll just skip to the next slide. And so we're going to talk about sort of introducing the material, introducing what Hanford is, and what the tank waste is, where it came from, what the treatment approach is, what is vitrification. We talk about that. We'll talk about that in detail. It's sort of an interesting word and not everybody knows it. And we'll talk about what the Washington State Department of Ecology's role is in this whole process of getting tank waste treated. And then we're going to hopefully have time for some great discussion. And so just a little bit about Hanford and why is Hanford here. And Hanford is part of the Manhattan Project, which started in the 1940s. It was part of a complex of facilities that existed across the country to build weapons-grade plutonium for the nuclear arsenal, both during World War II and during the Cold War. And with that came a series of systems that ended up with a lot of waste. And some of that waste is solid, some of it's liquid, some of it got disposed to the ground, and the worst of the worst waste ended up in tanks. And next slide. So that worst of the worst waste ended up in tanks, and you can see the tanks there. They're above the ground there because they were being built. But now all of the tanks, there's 177 of them are covered up, and they're all underground. They're carbon steel. There are different types. I'll talk about those and the different types in a minute. But how much waste is there? So all that plutonium production for all of that time ended up producing what is now currently 56 million gallons of high-level radioactive waste with a lot of chemicals in it. And if you put, how can you imagine how much waste that is? It's a huge number, right? If you put it on a football field, it would, cover up the football field and be 150 feet tall. And besides being highly radioactive waste that has plutonium and americium and all of those radionuclide sounding names, it also has a tremendous amount of chemicals in it as well. And if you looked at it, about a third of that is liquid, and another third of it is salt cake, which is sort of a precipitated, dried out, desiccated mass. And then another third of it is more of sort of a peanut butter sludge, or more like a mud. And each one of the tanks has some version of these. Some of the tanks have all three versions. And currently it's stored in, well, there's a total of 177 underground storage tanks. Most of them are up to 1 million gallons in size. Not all of them are that big. 28 of them are double shell tanks. I'll talk about that more in a minute. And 149 of them are single shell tanks. I'll talk about that more. And the older ones are the single shell tanks. And they have had a long life, and some of them have leaked significantly to the ground and added to the groundwater contamination. Next slide, please. So, as I said, there were these single shell tanks, and there's 149 of those. Now, fortunately, 21 or so of those tanks have had their contents removed or retrieved and moved over to the safer, newer, more compliant double shell tanks. And, some of these tanks exist from the 40s. They started in the 40s and 50s. And the single shell tanks have a single wall of carbon steel. They have no leak detection immediately around them. In the soil around them, there's some leak detection, but it's not a perfect system by any means. And, 50 to 67 of those have leaked to the ground, and 1 million plus gallons, and that has gone through the soil and gone to the groundwater beneath about 200 feet and added to some pretty significant groundwater contamination plumes underneath the central part of Hanford. Now, those are the older tanks, and there's newer double shell tanks. There's 28 of them. They tend to be more in that 1 million gallon size consistently across all of them. And we've had to take one out of service because it leaked. Now the double shell tanks have two walls, so they have two liners. So that's adding to the protection, and there's leak detection in between the two liners. And so they're a more robust tank, and they're closer to being a compliant tank. Go ahead, please. So just to give you a little bit of a picture, because some of these pictures are sort of stunning to look at, right? This is looking down inside of a tank, and there's different pipes and whatever that come down from the top of the tank into the waste, and that's waste at the bottom of this tank, or towards the bottom. And you can see the side walls and the ribs on the side of the tank. And this is a tank that's had some of its waste removed, but not all of it. And so how does the Washington State Department of Ecology regulate the tank waste? And I'll just talk through a series of different things. So there's a thing called the Tri-Party Agreement. It's also more formally called the Hanford Facility Consent Order and Agreement. And it's an agreement between three parties it's with the U.S. Department of Energy, who's the owner-operator of the site, and the U.S. Environmental Protection Agency, or EPA, and the Washington State Department of Ecology. And the EPA and Washington State Department of Ecology are regulators in that agreement. And Department of Energy is the owner-operator and does some self-regulation on some of the radionuclides and some of the rules around radionuclides. And what the Tri-Party does is organizes all those rules, defines who's in charge of what, and leads out a schedule for the cleanup of Hanford. And the cleanup's been going on for a couple of decades. It will go on for a couple of more decades, 3, 4 more decades. And so it lays out that schedule. There's also a similar document, but it's just between the Department of Energy and the Washington State Department of Ecology. And it's a consent decree that's signed in front of a judge. And it takes the schedule for the near-term building of the waste treatment plant and the waste treatment systems and puts that in a schedule in front of a federal court. And it takes the near-term retrievals of we talked about getting the waste out of the single shell tanks and moving it to the double shell tanks. It puts those two things into a decree that's signed in front of a federal court. And then the other way, and probably the way that is most important and most effective, is that there's various environmental laws that the Department of Ecology implements out on the Hanford site, and does it in various ways and various permits. And we'll talk about some of that more later. Thank you. Next slide. So what's the general treatment approach? What are you going to do with all that 56 million gallons of waste? Well, at the bottom of this picture, you can see that those are the single shell tanks, and that's a cutaway, and they're underneath the ground, and it's a pictorial picture of them. So what you want to do is get the waste out of those tanks and into the safer double shell tanks, which is the middle picture of the tank system. And then you want to get that waste into a treatment system. Now, obviously, it's a big risk reduction to get it out of the single shell tanks and into the double shell tanks. That's a huge risk reduction. But as you can imagine, there's only so much space in 27 tanks to be able to move all that waste. So you need to be able to treat it. Plus, in the end, you want to be able to treat it so that you can finally dispose of it and get the waste, the risk completely mitigated from the waste. And so when you think about that sludge that I talked about, that sludge contains most of the radionuclides and the radionuclides that you would want to be most protected from. And that will get separated through the treatment plant, and that will be vitrified, and that will go to an on-site and vitrified. We'll talk about that in a minute. So, but it gets glassified. It gets put into glass, and that will be stored on site. And that turns out to be 10% of the volume, but most of the radionuclides. And then it will eventually go to a deep geologic repository. And that deep geologic repository, buried under a mountain somewhere or someplace like that, will keep anybody from ever getting into it, because these radionuclides have millions of years of half-life. So they're going to last for a long time. And so you want to be able to have a really good waste form, which is the glassification, putting it in glass, and you want to put it away, locked up deeply away from so few people in the future, thousands of years in the future, can't have access to it and won't accidentally stumble upon it. So that's the pathway if you're part of the sludge, right? Now, if you're part of the liquid or the salt cake, which is primarily has a lot of the chemicals, but still some of the radionuclides. So that turns out to be about 90% of the volume and a smaller amount of the radionuclides. And not to say that the radionuclides aren't important, because some of the ones that stay there are highly mobile and last a long time, but you've significantly reduced by separations the amount of radionuclides in that waste. That waste is also going to be vitrified and going to be put in canisters and go to on-site disposal at a typical landfill, a landfill that has a system underneath it to catch leachate and things like that. So in that case, it's the glass the waste form, that's doing the major protection for keeping it out of the environment. Next slide, please. So that now, I skipped over the treatment, right? I skipped right past it in that last slide because I knew I was going to discuss it in more detail here. And I'll sort of discuss from left to right on the picture. So this is the waste treatment plant complex. It's actually about 20 facilities and 5 major facilities. And the first one on the upper left-hand side is the pretreatment facility, and it does that separation of high level to low activity. And the one directly beneath it is the high level waste vitrification facility, or the facility that's going to turn the high level waste into glass. And then over to the right of it is the low activity waste facility, which you can see it's complete. So those other two facilities I just talked about are about 50% complete. Now the low activity waste facility and the other facilities around there are all completed. They're completed, and in fact, this is the exciting part. They're going through all of the things that you do to start up a plant. You start and you do small startups with not waste. You test it with simulant waste, and you make sure that all the systems work. First you test it with water, then you test it with easy simulant, not real waste, and then you go to sort of harder, not real waste, but still simulant waste. And so this bottom one in the middle is the low activity vitrification facility, which we're going to spend a lot of time talking about. Right above there is a really state-of-the-art analytical lab that helps the whole thing do its job. And then on top of that is an effluent management facility, which is the fancy word for evaporators. So when you have a vitrification facility, which is a thermal treatment thing, so it heats things up, you're going to have off gas, and those off gases are going to produce liquids. And so you have to manage that large amount of liquids. And so you use the evaporators to help you manage that liquid. Next slide, please. So I promised I'd talk about what's vitrification. So we're going to talk about it here. And you can see the arrows come down for both the high level component and the low activity component. I'm just going to really sort of talk through one, because in general, the steps are the same no matter which one you're doing. So you get the waste out of the tanks, you pre-treat it into, you separate it into its high level component or its low activity component. And then it goes into a tank system. And in that tank, you mix it with glass formers. And primarily those glass formers are a lot of sand or silica. But there's other important things in it. There's boron, there's zircon, there's hematite or iron, there's olivine, there's other things. And it's a really prescriptive set of recipes per each batch of tank waste that comes over, so that you can make sure that the glass that you're going to make in the end is a really durable glass for that specific batch of waste. And so then that mixture of glass formers and waste then goes into the melter. And we're going to talk a lot more about the melter in a minute. So it goes into the melter. And think about the melter as a crock pot, right? You know how your crock pot works. It heats from the outside in. The outside heats up, and then inside your stew gets warmer and warmer, and then pretty soon it's bubbling and it's kind of turning over, and the onions that you put on the bottom are now on the top, and things like that. So that's how a melter works. It's heated, or at least that's how these melters work. It's heated from the outside, and eventually the material that you put inside, that waste combined with all those glass formers, start to meld together and grow together and become a molten set of glass. And you have this molten glass that's then poured out of the melter into a shorter low activity container, or a taller high level container, depending on which system you're talking about. And we can go to the next slide, please. So here's our giant crock pot. And this is before it was rolled into the building. And you can see how big it is by looking at the people around it, right? You can see that it's 3 times as tall as a person. And this is the thing that I always get super excited about when I'm talking about Hanford tank waste treatment, is that these melters are really state-of-the-art melters. They don't exist anywhere else. There's other melters, other places, and we'll talk about that in a minute, but these melters are just large, really wonders of engineering feats. And so this is the melter before it's rolled in on rails into the facility. There's 2 of them, and they last about 5 years. Maybe they'll last longer, and then you change them out. And go ahead with the next slide, please. So, and this is why I get excited, because the blue is one of those melters you were just looking at. It's a 15 ton per day melter. And then there's a second one. So we got a total of 30 metric tons per day in our melting capacity. That's on the low activity side. On the high level side, our melters are a little bit smaller. They're 3 metric tons. And so you kind of might say, well, what's the big deal? Well, okay, when you look at melters that are around the world that exist for treating waste, They are not, none of them are the size of our low activity melters. We're 3 times as large as the next size melter. And, there's waste treatment going on by vitrification in England and over in Savannah River in South Carolina, in France. They've already finished their work in New York. And all of those melters, you can see they're the green ones there, are all significantly smaller than our melters. And even our high level melters, the ones in the red, are on the large size as well. So the exciting thing is that we've just got these cutting edge, large facilities that are large melters that are really pushing the envelope of what has existed previously, and we're about to really start using them to turn waste into glass. Go ahead. So here we are looking down with the roof cut off for the picture of the low activity vitrification facility. And this bottom area, the sort of thing that comes out on the bottom, is where that melter was sitting. And you can see the rails, and it was pushed into where it's currently located in the red box. And then the second one was pushed in. And around the facility, there's a series of support tanks that do a series of different things. They combine the waste with the glass formers. They take care of effluents, and then you can also see a tremendous amount of pipes. And so we're not looking below what's below this floor, and we're not looking above. If we were looking at a slice above, you would see a tremendous amount of off-gas systems. And we'll talk about those in more detail. If you looked below, you would see systems that handle the canisters full of hot glass after they're filled. And so that's the layout of the facility and what it does. Go ahead. So about a decade ago, the going idea was that the whole waste treatment plant, all of those 20 buildings, and would start up all at once, and it would all run together. And just through a series of things, it was decided that let's get one facility up and going, and get one working and be working on getting the other ones working. And so they came up with an approach, and the Department of Ecology agreed with it, of doing a direct feed low activity system. So, and why direct feed? Well, we're going to bypass the pre-treatment plant, which is located, you can sort of see it's got a crane next to it, and it's because it's not completed. So instead of waiting for the pre-treatment plant to be completed, we're going to bypass the pre-treatment plant, and the waste is going to come out of the tank system and start at the orange arrow. And then it's going to go to an interim pre-treatment system that has been built since we decided to do this direct feed approach. And there it will have its cesium removed and be filtered for strontium. And then the next orange arrow, it goes down to the low activity vitrification facility, and several waste streams come out of that. The big green arrow is the containers of glass going off to be disposed of at the landfill that you can see located at the end of the green arrow. And then, as I talked about before, anytime you have a melter system, these things are operating at 2100 degrees, you're going to have off gas. And because of that off gas, you're going to have off gas protection systems. And some of that produces a tremendous amount of water, or it's not water, it's liquid waste. And you have to be able to manage all of that liquid. So then that's going to go to the evaporators in that first little blue arrow. And then some of that will be sent back towards the melters. We'll talk more about that. Some of it will then go on to another effluent treatment facility. And there it will be treated and eventually sent to a place for it to be solidified and sent to, and then that also would be disposed of in the landfill. Next slide, please. So I just wanted to talk, and I'm going to talk through the bottom set of slides, the bottom set of pictures first, and then I'll talk about the upper part. So the waste feed comes in from that pre-treatment system, right, that we talked about, and it goes into the feed tank in the low activity VIT building, and that's actually the tank right there, and it's mixed with the glass formers. And then it goes into the melter, and this is a cartoon picture, cutaway picture of the melter or the giant crock pot, and it's heated up and it's brought up to temperature, and pretty soon the silica combines with the glass formers combine with the actual waste, and they're combining together, and they're crystallizing together, and they're reacting together, and they're becoming glass, molten glass. And then through this spout that's on the left-hand side of the picture, it is poured off, and it goes to the pour cave, which is located below it. And I like to think of that as a gigantic lazy Susan underneath the melter. There's two of them, one under each melter. And each of those lazy Susan turnstiles have three of these glass containers, and rotated underneath the glass pouring, and they're filled up. And then the next one's rotated and they're filled up, and you keep going like that. And so you end up with the glass container full of glass that we talked about eventually goes to the landfill. So that gives you an idea, if you were the waste and you were going through the building, what you would be going through. And then I just wanted to talk a little bit more about the liquid waste. So in this heating up, you produce off gas, and the off gas results in liquids. But the liquids still have some things that you'd like to get incorporated into the glass. And so those liquids go to this evaporator system, the effluent management facility on the left, and they get separated, and the more contaminated portion gets sent back past the melter. And this goes in a circle, and the worst stuff gets passed back past the melter and back past the melter, so that you're trying to, for the nasties in the waste, get as much of those out of that liquid and into the glass as possible. And the more times you pass through, the more uptake you get into the glass. And that's preventing the secondary waste from being problematic in the future. And go ahead, please. So I promised that we would talk about how does Washington State fit into this? What does Department of Ecology do, right? And we have various permits. We've had a water discharge permit as the facility was being constructed. We have an air permit that follows the Clean Air Act, and we have a dangerous waste permit. I'll talk about it in a little bit more detail. And the point of the air permit and the dangerous waste permit is to make sure that we're protective of the soil and the air and the groundwater and the people, and to make sure that the facility is run that way. And so one of the things you do in a dangerous waste permit is you have a series of different controls that are put on the facility when they're constructing it to make sure that, that the tanks have containment, and that have double containment, and have leak detection. And you make sure that there's ways to shut off the feed if there's a problem, and there's ways to monitor everything. And all that is built into the permit, and they're required to follow the permit. And because you can see, this is the low activity vitrification facility, and it's got a stack here, right? And that stack is going to have things that go off into the air column. And because of that, and because you're treating things, you're up to a temperature of 2100, you need to make sure that you are being protective of putting volatile things out into the air column. And so what's really exciting that's about to happen in the next couple of days is we're about to start the environmental performance test and the environmental performance demonstration test. And we don't do it on real waste, we do it on simulant waste. And I'll talk in detail in the next couple of slides about that. And the whole point of that test is to take simulant waste and spike it with materials and that the concentration of, and then you check the concentration going out the stack to make sure that all those off-gas systems are doing their job. Go ahead. So there's a series of pictures here, and I'm going to kind of walk through it. So this is the key features of doing that environmental test for a thermal treatment unit. And so you have, this is the top of the melters. Remember, we were looking at the side view of the melters before, right? And this is there's one melter in the foreground, right behind the guy in the blue helmet and the white suit. And then beyond that, by the other orange, there's another melter. And they're sort of the gray boxes underneath. And this is the top of them. And so this is where so the environmental performance demonstration test is required in the permit. and it's administered because we put it in the permit, and we will be out there monitoring them doing this test. And so they're going to take materials, and it's a test that over the whole time will take 41 days or more, but they'll take material and they'll spike it in the top of the melters. They'll inject it in the top of the melters, and the concentration of that, and it's certain constituents, and their concentration. And then the melter will do its job. It'll make its glass, and things will go to the off gas. And the different off gas systems that it goes to is it goes to a submerged bed scrubber to take out the liquids. It goes to HEPA filters that remove particles, and radionuclides and chemicals can be attached to those particles, so that you remove it for that reason. It goes through carbon beds and a catalytic oxidizer and a caustic scrubber, and all of those work to remove things like mercury and nitrogen oxide and ammonia. And so you finally get to the stack after you've gone through all this off-gas system, right? Meanwhile, the glass is going to that glass canister we talked about, but this case, we're talking about the gas and where the gas would go, or the air. And so then it goes to this stack, and you can see that there's a gentleman here, and he's inserting a probe to be able to sample inside the stack. And so during the environmental test, after they've spiked the material at the top of the melter, then they're testing it in this system on the roof. And they're testing for all the different things that I've mentioned, plus other ones. There's about 10 different test systems up there that are looking for all these different constituents, and you're looking to make sure that they are below the level that you expected them to be, or below the regulatory levels. And if you do this and you're successful and you have a successful test, then you know that when you're running the facility with real waste, that you're being protective of what's going out into the stack and out into the air column. Next slide, please. So I spent an awful lot of time talking about the low activity vitrification facility because it's going through its testing right now. It's about to become operational. As soon as it goes through its environmental performance testing and passes that, then they'll be able to take real tank waste and start feeding real tank waste through it. And then that will be a great time, because then we're getting tank waste out of the tanks, we're getting it into this plant, and we're vitrifying it, and we're being able to dispose of it. But I wanted to go and talk about the high level waste facility, because somebody might ask, okay, that's what you're doing with the low activity facility, and it's ready to operate, almost ready to operate. And, what's happening with the high level vitrification facility? And what's happening there was that we recognized through a series of negotiations with the Department of Energy and EPA that we wanted to pursue, that a smart thing to do was to pursue a direct feed approach on the high level plant as well, and not waiting for the pre-treatment system to be up and ready. And so it would receive waste from tank farms through a new vault system that will have to be built. It will vitrify the waste, and then its liquids, much the conversation that we just had, will have to go to a new liquid effluent facility that has evaporators for it as well. And the facility is currently about 50% built. It's planned to be hot commissioned in the 2030s, hopefully up and running in 2033 or so. And we're currently working on permitting the facility and getting all the permitting the facility so that they can install all the systems that are similar but not the same as some of the systems that I showed you on the low activity vitrification facility. And so the idea there is to take a stepwise approach and bring that facility up online before the pretreatment system is available as well. Next slide, please. So where does all this waste go after you've made it? So you've made glass, you've made high level glass, you've made low activity glass, and you've got some secondary waste. Where does it all go? Well, the low activity glass, which turns out to be 90% of the volume, and the secondary waste, which is not a small amount of volume either, gets disposed of in the integrated disposal facility, which is a landfill. It's a state-of-the-art landfill. You can see it's empty. It's waiting for this mission to start. And it's your typical landfill is permitted through the dangerous waste regulations. It's got leachate collection systems. It's got liners and double liners, and a tertiary system to look at. They collect the leachate underneath it. It'll eventually be covered as you put more and more waste in it. It'll eventually have a cap on it when it's done. And that's where the low activity vitrified waste goes and the associated secondary waste. And on the high level side, that waste is going to put in those longer canisters. They're about 14 feet tall. They're going to be stored on site in a permitted facility and be kept safe. I'd much rather have the waste in that glass and sitting for some years, maybe decades, and then having it sit in the tanks, because the tanks, they're prone to leak. And once it's in the glass, it can be safely stored. It'll be stored in a canister storage type building. And then eventually, when the nation figures out how to build a deep geologic repository and where to build a deep geologic repository, then that waste will be shipped there. And I think that's the last slide. So I had them put this picture on the last slide because this picture makes me super excited. This is the top of one of those low activity canisters with glass that's been with waste. Well, it wasn't waste, with simulated waste that was mixed with frit, that was then turned molten and then poured into this canister. They've been producing these canisters as they've been bringing this facility operational. Again, still, it's not on real waste yet. And I just love seeing the end of the product. I love seeing that glass matrix in there with the olivine colored minerals in there. And that's when you've gotten to the end, when we start making tank waste into a canister like that. And I would love to entertain questions and thank everybody for participating. I love to talk about this.
Thank you so much, Suzanne, for that wonderful presentation. It really is so amazing to have you in our team. I have a question here from Andrew that I'm going to go ahead and ask it. You mentioned the melters had an expected life of 5 years. Is it expected that all waste will be vitrified by then? Or will these require multiple batches of melters to be decommissioned and commissioned?
Yes, and so the last part is the answer. Hopefully, some of them will last longer than 5 years. In other places or in the country, they've lasted longer than 5 years. They monitor them to see when to take them out of service. You want to take them out of service before they failed, because you want to take them out of service and empty the glass out of it, empty the waste glass out of it, and they'll have new melters on standby, being able to be rolled in. And so they would ideally be operating one melter and then be able to change out the other melter and keep moving forward like that.
Perfect. Thank you. Next question is from Karen. She says, how long does it take to cool?
That's a really good question. Dan, do you know? I know that it goes down to that Lazy Susan in the bottom, and then there's a tunnel where it's brought along on a trolley, and then it's brought out into another part of the building and sits there until it's cool enough to put on the trucks to go to the landfill. I'm not sure I know the duration on how long it takes to cool.
Some estimates have indicated it takes about 30 hours to cool enough to be processed correctly.
Thanks. Great question.
Awesome. And then Jerry has a question. Have any of the double-walled tanks developed a leak in the inner shell?
Yes, one of them did, and it leaked into its outer shell, but not out into the environment. And it was emptied and taken out of service.
I have another question, actually, that I kind of noodled around while you were chatting. You were talking about the vitrification plant, and I believe you said that a specific formula has to be created for each tank separately. So can you kind of talk about that process? Like, how long is that process? What does that mean to get the right formula for that?
So they have been doing a tremendous amount of testing over the last couple of decades on looking at the specifics of our tank waste and what makes good glass and what the envelopes are of good glass. And so they know when they pre-sample the batches ahead of time what the waste is going to be like and which of the various formulas they need to do to tweak to get that good waste. I mean, to get the good glass.
Suzanne, on vitrification, and this is a question that I've gotten before when I am out in outreach events. So to get the small pieces of glass that we have, um, first, how much waste does it take to get that little piece of glass that we have? If you know, if you have any idea, and how much radiation is in these little pieces of glass, because it still has radiation, right?
Well, so, and maybe it'll show. Let's see if I gotta see if I can get the camera in the right place. See, that's an example um, of a piece of glass that I have, and now it's not none of those pieces that you've been near or you've held or that I'm holding are made from tank waste or from waste at all. They're made from simulants. They're made from things that imitate the waste, but that aren't radioactive and aren't dangerous. And now, in certain laboratories, they've had the actual tank waste and had a very small very small crucible size, like bowl size melters, and they've practiced with that.
Looks like we have another one. We've got one from Dwayne here. How many gallons of waste are planned to be treated annually through the low activity waste plant? And how many gallons of secondary waste are generated and must be further treated for every gallon of waste treated in the plant?
Yeah, Dwayne, that's a great question, and I'm not sure I have the facts right off the top of my head. I think that and Dan can jump in here or when I get done, but we have about 800,000 gallons of waste pre-treated and ready to go, and I think we think that will last a year, and the waste. Just trying to think of your question. You you end up, so the waste volume gets reduced, so glass reduces it, so you end up with less glass than you originally had in actual waste, but you do end up with secondary waste in the forms of used HEPA filters and pumps, and then all that liquid waste that then solidified, and it's a significant volume. It's at least as it's a little. It's either 2/3 of the original volume or as much of the original volume. And Dan, help me out there. Do you have a better answer?
No, right now those estimates are pretty clear.
I think this is a follow-up question. So once running, um, does the melter run 24/7 or does it stop?
No, once running, the melter's running. It's not like your crock pot. You can't turn it on and off. Now, you can sort of turn down the volume of waste that's going into it, or you can even introduce just frit into it and be producing, just cleaner glass at the back end. But once you start running, you're running that melter.
And looks like we've got a little bit for you from James. He says, if I understood the sequence correctly, DOE is moving ahead with direct feed for both low activity waste and high level waste. What will be the point then of the pretreatment facilities if the plan is to bypass them, at least in the early years? And a related question, when will the pretreatment facility be completed, tested, and then put into service?
Well, that's a good question too. So part of the pretreatment system is already mimicked in the low activity pretreatment system that's over there by the tank farms. The system that removes the cesium and filters out any particles that might have strontium on it. So that system, that part that existed in the pretreatment system, has in part been replaced by that facility. And then that evaporator that got added is also a replacement for something that was in the pretreatment building as well. But what's not replaced anywhere yet is this need to wash the sludges. And you don't have to wash the sludges to make good glass. It's just that you have sludges that is that high level waste, and that high level waste needs to go to a deep geologic repository, and all that takes up money and time and space in a deep geologic repository. So the idea is that you want to wash as much of the chemicals out of that sludge so that they can stay here on site and be vitrified. And so the big thing that the pretreatment facility does that we don't already have a replacement part for is that sludge washing. And so they can, in 2030, you can bring up the high level vitrification plant and not wash the sludges and still make good glass. And you can do that, but you'll be treating, if you never replace the sludge washing capabilities, you'll be treating waste for a very long time and will be sending a bunch of chemicals to a deep geologic repository. So eventually, the Department of Energy would likely need to, and if you want to make the mission shorter, bring online the sludge washing facility. And there's, in the recent holistic negotiations, there was a set of decision points put out in the future for when a decision would be made on whether you're going to use the pretreatment facility that I was showing you, or some alternative pretreatment system that might be smaller buildings broken into different sizes.
Thank you, Suzanne. We have another question from Jerry. He asks, what becomes of the emptied tanks? Are they left in the ground and sealed?
So the plan for those, it was discussed in the tank closure waste management EIS. And the plan for those, they looked at various alternatives. Do you dig them up, the shells up? Do you leave them in the ground after you've emptied the tanks? Now the tanks are never completely empty. There's some residual down in there, and there's also contamination in the soils and the pipes. And so there's going to be a series of closure plans, which are permits, that are going to make the decision of what to do with the first. And I didn't really describe this. The tanks are in tank farms. Some of the tank farms have 12 tanks. Some of them have 16 tanks. So in a particular farm, the first farm to be emptied, they'll go through a closure permitting activity, and that will have public involvement with it. And during that time, they'll make the decision of either leaving them in place and closing them as a landfill. So they'd fill them up with material and they'd put a barrier, a landfill cap over the top. They might do other mitigation in the soils before that and things like that. And then they would maybe close them on site as a landfill. Or it may be that the tanks would be retrieved. The EIS looked at the question and made its decision and said that that it didn't make sense to remove the tank hulls out of the ground, that it was just too much exposure to workers who were having to cut up that steel and just move that stuff that was contaminated. And these things are huge. And so the EIS's direction was that we would do a landfill closure. that decision still needs to be formally and made again when we go through the permitting for the closure of the first tank farm.
And then kind of on that note, I'd like to go ahead and address Karen's question. What about safety for the workers out there?
Right, so that's super important, whether you're retrieving the tanks, or whether it's in one of these plants or people who are co-located around the plants. So Department of Energy does the regulation of the safety of the workers. That and Department of Ecology and the Environmental Protection Agency are very concerned that they're very concerned that it gets done and it gets done right, but the way that the people who regulate it and do the best job and are the experts at it is the Department of Energy. And so that's something that they regulate themselves. But our permits have to make sure that whatever's happening is not just protective for the air and the soil and the groundwater, but also for the workers. And so, that's why when we look at what might be off gassing we want to make sure that even if there's a worker that's located on another facility somewhere else, that they're going to be protected as well.
Okay, so we have a question from Andrew. Have they characterized all the tanks yet for those custom blends for vitrification? If not, do you know percentage-wise how far along they are on that part? Also, what happens to the cesium and strontium that you said was removed before vitrification?
Yeah, that's a good question too. I like that last part. So all the tanks, they have a sense. They call it the best basis inventory of what's in all the different tanks. Some of it's based on sampling, some of it's based on modeling. So if you have a really similar tank that went through really similar processes and they sampled that tank, and it's similar to these other two tanks, then they can do some projections of what that is. So the best basis inventory gives you a sense of what's in the various tanks. They will look and characterize the waste as they're getting it ready for the feed coming into after probably the interim pretreatment system. They'll look at that and be able to look at that and understand it better at that point. Oh, and then you asked about the cesium. So that pretreatment system is called a cesium ion exchange system. So it's like beads of ion exchange, and so the waste goes through these beads, and the cesium goes out and gets attached to the various beads, and then the waste coming out the bottom has a lot of its cesium removed. And prior to that, there's a filtration that happens as well that removes particles, and that's where the strontium would be. And then some strontium does end up on the beads as well, they're finding. And those are going to be stored. They are being stored because we've already pre-treated about 800,000 gallons. And those are currently being stored on a permitted facility. They're clamped to the ground with these clamp systems, and they are eventually going to be opened up and fed into, because that is high level waste. The reason you remove that is because that's the key constituents that makes that waste high level. And by removing it, you can now call the waste low activity. And so that cesium and strontium has to get bled into the front end of the high level waste vitrification plant, or in the future, if it could get just shipped directly to the deep geologic repository, that would be okay too. And that would assume that the repository would be okay with it in that form.
So let's kind of go back inside the melters real quick with this question. With the heat of the melter, does the melting process change the radioactive elements or chemical makeup of the waste?
Some of it obviously changes the chemical makeup of the waste. Things get off gas, so they go from being in their liquid form to being in a gaseous form, right? And they'll combine with other things. So obviously, if you're ending up with mercury in the off-gas systems or nitrogen oxides, or then you have changed the chemistry on the inside, because that some of those chemicals have left and gone to the off-gas. From the radionuclides, I might ask Dan if he's got an example. I can't think of any of the radionuclides that change because of vitrification. Now, before you answer, Dan, some of those radionuclides can be volatile. Technetium 99 can be volatile, and so can iodine 129, and they can be volatile. But that's why you have that off-gas system that goes in a circle and goes past the melters again and again, so that you're forcing those constituents into the glass over and over again. Dan, do you have any other examples?
I do not.
Okay, so Ben is asking, what goes into deciding the recipe for the glass melters with the different composition of each of the tank waste types? And he also said that he loved the crockpot analogy.
So there's some really good technical documents out there on that, and I don't know if public involvement wants to commit to sort of putting those on one of our websites, but there was a recent one that was published in a journal that had some really good detailed scientific chemical explanations of what goes into the recipes. A lot of the times what they're looking at is what constituents that's in the waste that might make the glass less durable, and what do we need to do to those constituents to keep them within an envelope of having a durable glass. And there's various different tests, and I won't get into them, that they do on the glass to show that it's meeting its test criteria. And so without being able to get into a detailed paper like that I think that's probably my best answer. Is there's some good information out there on it. There are really good reads.
I would love to ask a question about permitting really fast. So talking about the high-level waste facility and the new systems that it requires to be built, what is the process of permitting that? Is that like a new permit, or is it a modification of current permits?
So the continuation of the high-level vitrification building would just be a continuation of that permit. So they'd be getting us the design material of the next thing to be installed. We'd be reviewing it and doing it, and if it's big enough, then we would take it out for public comment and get public comment, and then we would put it in the permit. We'd respond to public comment, and we put it in the permit. Then they could install that system, whichever system we're talking about. That's the high level building. And then on the new facilities, the vault and the new high level evaporator system, those you're starting at ground zero. They have to give us a permit application, and that's usually sort of like all the design information and the process description and how the facility is going to operate and what's the contingency for this or that happening. And there's all these different chapters of a permit that they give it to us in an application. We review it. We give them comments back. We ask for more material where we need more material. We then we go back and forth like that, and then we write the permit. We write all these various chapters on training and contingency and process, and what the waste sheets, what the waste cutoffs are, and what all the different controls are in the facility. And then we go out to public comment with that, and we get public comment. And sometimes we get really great public comment that points out things that we didn't think of, and we then incorporate some of those things into the permit. And we then issue the permit so that they can start constructing it. And then while they construct it, we're out there doing oversight to make sure they're constructing it according to the permit.
How are you doing, Suzanne? Ready for
I'm
more
doing.
questions?
I'm good. I'm excited.
Yes, this is great conversation. Okay, so I'm gonna go with James's question now. He says, I understood that DOE reclassified at least some of the high level waste in tanks as transuranic waste. If so, would not that allow disposal of at least some of this waste at WIP, WIPP?
Right. So just so that people know, the waste isolation pilot plant is a deep geologic repository, but it only exists for transuranic waste and not for high level waste or for spent fuel. And it's so some of the tank waste Department of Energy has made an argument for, but they've never actually gone through the whole hoop to reclassify it, that they feel that some of the tanks, about 9 of them, are, they believe, might be transuranic waste because they never came from the reprocessing of spent fuel. And on some of them, they have a great story. On some of the other ones, the story's a little different. And so Department of Energy hasn't finished looking at that and has kind of let that sit for a little bit. If they do, if they're able to say that XYZ tanks are transuranic, then they'd be able to extract that waste, put it through a drying system, which would have to be a permitted facility, a new facility, and then ship it to WIP, to the waste isolation pilot plant.
Sounds incredibly involved. Here's a fun question. What about robots and AI? What are the uses and applications of that in waste treatment?
Oh, that's a good question. Oh, Dan, I might punt that to you if you have any thoughts. Well, go ahead, Dan. I'm going to let you answer because there are robots there.
Well, what I can say is that robotic devices are already being used. Some of them are called crawlers, and they get into tanks and check things out, take pictures, and that sort of thing. You might not call it a robot of sorts, but extended reach sluicing systems and a variety of other things are all mechanical and hydraulic in nature, and they're used periodically inside the tanks to get work done as well. Suzanne?
Yeah, and that's a great answer, Dan. And within the waste treatment plant, there's also so much of this is not handled by humans, right? So there's trolleys that move the waste along. There's grapplers that pick up things and move it along as well.
And I have my own follow-up to that. When we're thinking about the single shell and double shell tanks, is there like a lifespan associated to the pipes and the tubes going into all of that waste? Like, are they being damaged at some kind of crazy rate requiring frequent replacements, or are they actually standing up pretty well?
So the system that already exists out at Hanford is on the single shells is many years past its design life, and for the most part, it's still holding on to the waste, except for those tanks that have leaked. And again, in that case, the liquids leaked, the solids didn't come out of it. Um, and there's pipelines across the site that they've had to take in and out of service as well. And we talked about that one double shell tank that had to be taken out of service because it leaked from the inner shell to the outer shell. Within the waste treatment plant, it has a design life of 40 years. If it's like other parts of Hanford, it will probably be able to exceed its design life. And there are systems that especially on the low activity side, that can be replaced easily. Well, I don't know about easily. Nothing is easy at Hanford, but and when
I
they
have
design it, they look at all the what the chemistry of it is, and if there's particles going through the pipes that are going to erode the inside of the pipes, and what the chemistry is going to change, and you know, some of the tanks have walls that are, you know, this thick or more, you know, of stainless steel.
one more question. So Jerry is asking, are there any radioactive gases involved in handling this waste?
So that's a good question. I mean, I guess when the iodine and technetium off gas into when you're heating them up, they go into their gaseous form at some point, but then they get scrubbed out in the scrubbers and go back into a liquid form. Um, in the tank waste, I don't really believe there's radioactive gases that I can think of. Dan, can you think of any?
Not offhand, no.
All right, looks like we have another one from James. And then if anyone would like to ask their own question, please feel free to raise your little hand and we'll get to you here. So James says, oh wait, I think I'm looking at the wrong thing. What are the next permit applications for new facilities or PMRs for existing ones? You might expect DOE to submit, and when might the public expect to see them?
That's a great question as well. So that so if we're talking about the low activity waste facilities and the facilities that support it, um, the permits are complete for all of those facilities. We're still going through some permit modifications as they get that facility operational, and there'll be one permit modification at the end after the environmental testing, and while just as it starts treating high level, I mean, just as it starts treating tank waste, there's going to be a permit mod there. There's likely to be other small permit mods as they have to change things and modify things, because as when you start anything up, things aren't quite the way you wanted them to be, changing valves and things like that. And they'll redo the environmental. So before a couple of years ago, an environmental risk assessment was done, and they looked at all the things going to the off gases, and they modeled it out to its impacts and to its impacts on people and biota and animals, and they'll once they've run the environmental demonstration test and have actual data on what actually goes where, then they'll plug that new data into the assumptions that were in the risk assessment, and they'll redo the risk assessment to again further demonstrate that the facility is safe and protective because of the air emissions. In addition, the low activity pretreatment system that does that ion exchange was built at a pilot scale. And so it's only able to feed about a half of what you would need in a given year. The good thing is it's pre-treated, it's pre-treated a bunch of waste so that we have some backup waste ready. And then as we're using that waste, it will start filling in that backup space. But there's another facility that's like it, that's going to be about twice as big as it, that's going to be built in a similar location, very near to it, and it's called Advanced Modular Pretreatment System, or AMPS, and it's going to and we probably will see. We're going to start to see permit application material from them in this year, next year timeframe, and there'll be public comment associated with that larger pretreatment system. And then, as I said before, on the high level facility, we'll be permitting, and some of those permit modifications will go out for public comment on the actual vitrification facility, and then eventually on the vault facility and the high level effluent management evaporator system as well.
One very quick follow-up. James is asking, would you expect those startup mods to be class 2 or 3?
For a brand new facility, they would be a class 3 for sure. Which for other people, that means it goes out, the Department of Energy takes it out to their application, out to public comment, and collects public comment. and then we all are the benefit of that public comment, and then we write the permit and take that out to public comment, and then modify the permit as necessary due to that public comment.
Awesome. Looks like we have another one from Andrew in the chat, and then I think that's our last chat one, maybe. Where'd it go? Okay. Is there any crossover to the energy industry? Could the VIT plant be used for anything after the Hanford cleanup mission, or apply lessons learned for industry waste handling?
Well, the interesting thing about Hanford, and anybody who's online who's a Hanfordite would know this, that a lot of the things that happened out on site to come up with the plutonium and to create the plutonium in the reprocessing plants, which was actually the start of our large chemical works in the United States, and so it plugged into the large chemical works that exist across the country, and the petroleum chemical works as well. A lot of the systems were similar. And then also true is a lot of the off-gas systems that we're using and deploying came at the Hanford plant, at the waste treatment plant, have come out and been developed from the petroleum industry and other chemical industries, because they also want to be protective of the air. So there's a lot of crossover back and forth there. I think the Hanford vitrification facilities will be busy for many years, decades, multiple decades, treating the tank waste. And I think by the time they get that done, they'll probably be at the end of their design life. There was some thought along the road that maybe some of the similar waste that exists in Idaho might come over here after we were done, and then we would vitrify their waste. I believe they figured out other pathways for their waste, but things like that are sometimes a possibility. But I haven't heard that discussed in the last decade or so.
All right. I would like to open it up once more to anyone who wants to ask their own question. Going once. All right.
Well, I can ask one, Suzanne. I had a question for you. I can't let you get away without me asking one. Um, you've been working on tank waste and Hanford Mission for a long time, and I was just curious what your kind of perspective is. You've seen this treatment plant get up, and you've seen the commissioning process start the first couple of years. I know you talked about the test glass that was being poured and all of the things that you're excited about. But what has it been like for you to see this plant kind of come online the last couple of years, and to see glass being poured soon?
Yeah, so I love that question. I mean, I was here before the plant existed, when they were trying to do the plant under different mechanisms. They were going to privatize it and borrow money and do things like that, and then they switched over to this approach. And out there, when it was just a blank field, where you saw all those 20 buildings, it's just a blank field, and writing these really extensive permits. And the thing is it's not just me, right? I mean, I've been here for a long time, but we have engineers and permit writers, and there's 17 people in our section that work on this, or work on things related to this, and those people have come and gone, and they've all contributed significantly. And so some of my favorite part is the contributions that the state has made, and the detailed reviews that we've done, that we know we did our job right, and that people rolled up their shirt sleeves and recalculated things just to make sure that things were calculated correctly. Or we have one of our engineers that always just finds everything, and was walking around at the site when the tanks were first being built in the pretreatment building, and she noticed there wasn't wear plates at the bottom of the tank where there should have been wear plates, and it was an accident. It wasn't, and so that's some of my favorite things, but it is super, our section is so excited right now because we've seen a bunch of test glass being poured. We got to go out and sign one of the canisters full of test glass. And, that was exciting. We're starting next week on going out there for the environmental performance testing, and to see all the things that you barely knew about in the beginning to then become the testing, to then become the test that we're actually going to start on next week, and to know that it all has a purpose to protect the bugs and bunnies and the people, etc., and the air. That's and to know that once the treatment plant is up and going, that this is, granted it's just the one treatment plant, but that to know that then we're going to be taking waste out of tanks where it can't leak anymore to the ground and going to be turning it into glass. That's the super exciting part.
Well, thank you, Suzanne. I absolutely agree. This is super exciting. And I just want to thank all of the thanks in the chat. We love to hear that you guys like hearing about this. We like talking about it. It's really cool. It's really exciting. So with that, I think if that's all of our questions, we would love, again, thank you so much for being here and attending tonight, asking your questions and watching. That's awesome. Thank you so much. This event was recorded. It will be up shortly on both the Ecology Facebook pages and the Ecology YouTube channel. And we will also add a recording link to our website. So thank you again. Do you have any final thoughts, Anna Griselle?
Yes, thank you, Sarah. It was really a pleasure co-hosting this event with you. I
Pleasure's
did
mine.
want to read a couple comments that we got in the chat just now. I think Suzanne is going to like hearing them. It says, Karen from Seattle says, thank you. This has been very helpful. I would love a cartoon explaining how the uranium turned into plutonium and how the waste then changes into so many dangerous chemicals. And then James Birzy, I hope I'm saying that right, says, thanks, government, for the presentation and especially the thoughtful and complete answers. Suzanne is an amazing fount of knowledge, and the state of Washington should be grateful for her service. I know I am. That was very nice.
Very nice.
And with that, I just want to say a final reminder for our attendees to reach out with any other questions that you might have and to stay tuned for future events. If you have any ideas of anything you would like us to cover, please let us know. We're always looking for other things to bring you topics that are fun and that are that you are in need of information for. And with that, I want to ask Suzanne, do you have any final thoughts for tonight's presentation?
Well, I appreciate everybody being here, and I appreciate all the people that I work with, all the engineers and permit writers that are so smart, and the chemists and the hydrogeologists that are so smart, and just make it easy for me to do my job. So
thank you, Suzanne. And with that, we finish this event. Thank you again for attending tonight's conversation, and we'll see you next time.